Everyone's seen Venus in the sky, but almost no one has actually seen Venus. For years, the surface was a complete mystery, hidden behind clouds so thick not even light could get through. No photos, no color, just guesses. Until now. What you're about to see are the real images of Venus. Photos taken from the ground, scans from orbit, and shots captured by spacecraft not even designed to look at it. If you're fascinated by the hidden wonders of our universe, hit that subscribe button and join the Stellify science community. You won't want to miss what we uncover next. They said it couldn't be done. To be fair, they were mostly right. In the 1970s and 80s, Venus was the ultimate proving ground for any spacecraft claiming it could survive anywhere. Because this wasn't Mars, where rovers can casually explore for years. Venus was the real deal. A hellscape so brutal that sending a machine there felt more like throwing it into a furnace and hoping to hear a scream before the line went dead. But the Soviets tried anyway. Between 1961 and 1984, the Soviet Union launched more than a dozen probes toward Venus. Most failed. A few burned up in the atmosphere. Some missed the planet entirely. But in 1975, something incredible happened. Venera 9 touched down. It didn't just survive for a few seconds. It lasted approximately 50 minutes before succumbing to Venus's extreme heat and pressure. And in that window, it sent back what no one had ever seen before. The first image from the surface of any planet other than Earth. It wasn't pretty. The photo was black and white, grainy. The frame was warped, and the camera, tilted slightly, pointed toward a mess of flat rocks that looked more like a construction site than an alien world. But the gravity of it, no pun intended, was undeniable. This was not a CGI render. It wasn't a radar scan or an artist's guess. These were real stones on a real alien world, beamed back from 38 million kilometers away. Days later, Venera 10 did it again, landing just 200 kilometers from Venera 9. It lasted 65 minutes, long enough to transmit another eerie photo filled with cracked slabs of rock under a haze. And then came the Venera 13 and 14 missions in 1982. That's when things really got weird. Venera 13 didn't just take photos, it brought color. It captured sound. It even drilled into the surface and analyzed the soil. And when its image came back, it shocked the world. The sky looked like something out of a nightmare. A deep sulfur yellow tone, probably tinted by sulfur dioxide and volcanic gases. The ground was covered in flat, interlocking rocks that looked like the crust of an overbaked pie. These weren't artist impressions. They were real, raw, distorted by heat, yes, but unfiltered. Exactly as seen by a robotic eye that was dying while it sent them. What those early Venera missions proved was simple. Venus is not some smooth marble covered in clouds. It's broken, violent, and uninviting. Yet somehow, in those short periods of survival, humanity got a glimpse of a place that had rejected every other visitor. And that was just the beginning. You can't just point a camera at Venus and hope for a clear picture. That's not how it works. The planet is wrapped in clouds so thick, so toxic, and so reflective that visible light doesn't stand a chance. It's not fog. It's more like trying to see through a blanket soaked in acid. The atmosphere is made of carbon dioxide, pressurized to over 90 times Earth's level, and laced with sulfuric acid droplets. From space, Venus looks like a smooth yellowish orb. Completely blank, totally featureless. For decades, that's all anyone could see. So, scientists changed tactics. If you can't look through something, you bounce something off it. Enter radar mapping. In 1989, NASA launched the Magellan spacecraft, a mission that didn't care about pretty photos. Instead, it was equipped with a powerful synthetic aperture radar, SAR system, that would orbit Venus and send radio waves straight through the clouds. Those waves would hit the surface, reflect back, and be reconstructed into high-resolution images, not of light, but of texture, elevation, and structure. Magellan entered Venus orbit in 1990 and spent the next 4 years doing one thing obsessively: mapping. The results were stunning. Not artistic, not colorful, but stunning. Magellan mapped 98% of Venus's surface with a resolution as fine as 100 meters per pixel. It revealed massive shield volcanoes larger than anything on Earth, endless lava plains more like a dried-up ocean of molten rock than anything geological, miles-wide pancake domes, fractured terrain that looked like a planet trying to tear itself apart, and highland regions like Ishtar Terra and Aphrodite Terra, towering as much as 11 kilometers above the lowlands. This was not a twin of Earth. This was a planet frozen in geologic chaos. Some areas were smoother than expected. Others were completely shattered. Some slopes reflected radar more strongly, indicating rougher material or different compositions. But the biggest shock was how young it looked. Based on crater counts, scientists realized the surface was probably no more than 300 to 500 million years old. That's recent, which suggested something wild. At some point, Venus might have resurfaced itself, melted everything down, and started fresh. Magellan didn't just send back data, it built a 3D world. Later, scientists used Magellan's radar to generate false color topographic maps. They lit it with simulated sunlight, added digital elevation, and made the first 3D visualizations of Venus's surface. Even if we couldn't see it with our eyes, we could now walk through it virtually, fly over valleys, stand atop mountains, and trace the fractures of a shattered plain. The irony: Magellan wasn't even supposed to last that long. It kept going, mapping, repeating orbits, refining scans, until finally, it was deliberately crashed into the planet in 1994. A fiery end, but one that sealed its legacy as the first mission to truly reveal Venus. What it showed us was this: underneath the clouds, Venus isn't smooth or boring. It's scarred, shaped by eruptions, crushed by its own pressure. It's an alien landscape that looks like Earth after something went very, very wrong. But here's the thing: that radar map was just the beginning. Scientists didn't stop at orbit. They started bouncing signals off Venus from Earth itself. And the results were even more surprising. It sounds almost impossible when you first hear it, that we could map the surface of a planet cloaked in clouds from Earth, with no orbiters, no flybys, no satellites, just telescopes on the ground, aiming radar waves across millions of kilometers and listening for the faintest whisper of an echo. But that's exactly what scientists did. While spacecraft like Magellan were busy mapping Venus from orbit, another group of researchers was using something far less flashy: Earth-based radar systems. The technique is deceptively simple. A massive radio telescope like Arecibo in Puerto Rico fires pulses of radar waves toward Venus. Those waves hit the surface and scatter. Some bounce straight back toward Earth and are picked up by a second dish, often the Green Bank Telescope in West Virginia. This is called bistatic radar. It's not new, but Venus made it incredibly difficult. The signal has to travel across space, bounce off a brutally rough surface, and come back with enough strength to be decoded. A one-way trip can take over 2 minutes, and by the time it gets back, the signal is so faint it's nearly buried in noise. And yet, it works. In the early 2000s, scientists began publishing startlingly detailed radar maps of Venus generated entirely from Earth. These weren't artistic impressions. They showed real surface features, volcanoes, ridges, valleys, craters, with a resolution comparable to orbital maps. While they couldn't match Magellan's 100-meter resolution, they offered something else: change over time. Because these ground-based systems could remap areas repeatedly, they allowed researchers to compare snapshots of the same terrain years apart. And that's where things got interesting. Some features looked different, not just in brightness or noise, but in shape. There were signs of collapse, new lava flows, or subtle shifts in radar reflectivity, clues that something might be moving beneath the surface. One of the most fascinating areas is Inoplanetsia, a vast plain dotted with volcanic features. Radar scans from 2012 and 2020 suggested changes in surface texture that couldn't be explained by noise or software artifacts. Scientists began to wonder, was Venus still geologically active? Was it still resurfacing parts of itself, quietly erupting, or shifting deep crustal plates in ways we don't fully understand? Even more compelling, these Earth-based observations helped validate Magellan's findings. The areas that appeared rougher in Magellan's scans also bounced radar more strongly from Earth. The smoother plains, like Sedna Planitia, looked similarly dull in both datasets. It was a strange kind of long-distance confirmation, two totally different approaches producing eerily similar results. And this method isn't just a backup plan, it's ongoing. Even after the tragic collapse of Arecibo in 2020, radar work continues using other facilities. Green Bank has been paired with NASA's Deep Space Network antennas, and future plans include using phased arrays or potentially even lunar-based radar dishes for even clearer scans. The bottom line? We've never landed anything on 99% of Venus. We've never taken a photograph there. And yet, we've mapped it, tracked it, and even spotted possible signs of movement, all from a planet 38 million kilometers away, hidden under clouds, using nothing but bouncing radio waves. It's proof that sometimes to really see a place, you don't need to get close. You just need to know how to listen to the echo. Venus isn't shy. It's the third brightest object in Earth's sky after the sun and moon. You can spot it with the naked eye. It appears as the morning star or evening star near the horizon at dawn or dusk, depending on its orbital position. Its brightness has led to frequent misidentifications as aircraft or UFOs. But the weird part is, all that brightness is deceptive. What you're seeing isn't the planet. You're seeing its clouds. The actual surface still invisible, still hidden. That's why when the Parker Solar Probe captured images of Venus in visible light, the scientific world did a double take. This spacecraft wasn't even meant to study Venus. It was built to plunge repeatedly into the sun's outer atmosphere, enduring temperatures that would destroy most electronics. But to get there, it had to use Venus for gravitational assists. 7 flybys in total. During one of those early passes in 2020, NASA engineers decided to try something almost ridiculous. They pointed the probe's whisper camera, wide-field imager for solar probe, at Venus, and against all expectations, it worked. The images that came back weren't high-res. They weren't postcard-worthy. But they showed something we'd never seen before. Parts of the actual Venusian surface glowing faintly in visible light. Not radar, not infrared. Actual photons bouncing off the terrain and hitting a digital sensor. How? The key was timing and position. The probe flew close to the night side of Venus, where the temperature contrast between the hot surface and the cold upper atmosphere creates just enough of a glow to be seen. It's not reflected sunlight, it's thermal emission. faint light radiated by the rocks themselves in a narrow band of the near-infrared and visible spectrum. What we saw was real geology, ridges, plains, and highlands like Aphrodite Terra, emerging through the haze like ghostly shadows. The bright regions were likely hotter or composed of different materials, while the darker areas hinted at cooler or smoother plains. These differences could be tied to elevation, composition, or even ongoing volcanic activity. It was the first time we'd ever seen Venus like this, with visible light showing a real surface feature without needing radar. But that's not all. The Whisper camera also picked up a faint atmospheric glow, a halo of light coming from oxygen atoms high above the planet. This effect, called airglow, is similar to what we see on Earth in the form of auroras. And it gave scientists a new way to study Venus's upper atmosphere and how it interacts with solar radiation. What makes this moment so bizarre is the fact that it was never supposed to happen. Whisper was designed to look at the sun's corona. It wasn't calibrated for low-light imaging of planets. The camera had no filters optimized for Venus. No one expected it to see anything at all, but it turns out Parker was just in the right place, at the right angle, with just the right sensitivity to catch a glimpse of the planet that's been hiding in plain sight for decades. That one image changed the rules. Suddenly, the idea of imaging Venus in visible light didn't sound crazy. It became part of future mission planning. If a solar probe, flying past at 20 km/s, could do it without trying, what could we achieve if we actually built a mission designed for it? This new window, opened by Parker Solar Probe, isn't just a one-off moment. It's a hint that even the most cloud-shrouded worlds might reveal themselves, not through brute force, but through clever physics and a little luck. And maybe, just maybe, there's a lot more waiting beneath those clouds than we've ever dared imagine. In 2023, researchers digging back through old Magellan radar data found something strange. 2 images of the same volcanic vent, a place called Mont Mons, one of the tallest volcanoes on Venus, taken 8 months apart. And in the second image, the vent looked different. The shape had changed, the walls had collapsed, and radar reflections suggested fresh lava had flooded the floor. It was a quiet revelation, but a massive one. Venus wasn't dormant. It was still active. Then in 2024, another research team, this time using advanced image processing, analyzed thousands of Magellan scans. What they found blew the lid off old assumptions. A number of different volcanic features showed signs of recent change, not just at Mont Mons, but at Sapis Mons, Niobe Planitia, and other regions too. Some had fresh flows. Others had new cracks. A few even looked like domes had deflated, as if magma had withdrawn from underneath. These weren't eruptions we caught live, but they were before and after snapshots, evidence that something deep beneath the surface was shifting, pressurizing, and bursting out. And suddenly that old story, the one about Venus being dead, collapsed. The implications are huge. Volcanic activity means internal heat. It means the core hasn't cooled. The mantle hasn't gone still. It could mean Venus still has a lithosphere, mantle convection, maybe even hot spots like Earth's, fueling steady eruptions over time. And if the planet is venting heat, it could also be venting gases, sulfur dioxide, carbon monoxide, or even trace gases like phosphine, which some scientists controversially proposed as a possible biosignature in 2020. The atmosphere of Venus is thick and chaotic, but fresh volcanic eruptions could directly influence its composition, its dynamics, and its strange chemistry. That might explain why its upper atmosphere changes so much. why sulfuric acid levels fluctuate, why there are unexpected UV absorbers, and unexplained dark streaks in the cloud decks. All of that could trace back to the ground and to volcanoes that haven't stopped breathing. Here's the best part. We're about to get confirmation. NASA's upcoming Veritas mission and ESA's Envision orbiter, both scheduled for the early 2030s, are being designed with high-resolution radar and spectroscopic tools that can watch for active volcanism in real time. Not just a few vent changes, but flows, thermal spikes, and possible gas plumes. We might actually catch an eruption as it happens, something no one's ever done on Venus. And if that happens, if we see fire on a world that was once thought geologically silent, it's going to reshape how we think about inner planets, habitability, and Earth's own long-term future. Because Venus isn't dead, it's just hidden. And now that we know where to look, it's starting to show signs of life. Not biological life, but the kind that rises up from molten rock and reshapes a world in silence. Let's make something clear. Most people have seen Venus, but almost no one has actually seen Venus. When you search Venus online, you get dozens of polished visuals, beautiful spheres wrapped in orange or purple clouds. They look stunning, but they're not real. They're artistic interpretations, or filtered composites. The real images of Venus, they don't look polished. They look uncomfortable, unforgiving, and most of all, unfiltered. So, let's go through them one by one. Start with the Venera lander photos. These are some of the only real photos ever taken from the surface. No spacecraft since has managed to do the same. What you're looking at in these grainy, wide-angle panoramas is a flat, broken landscape. Pale, jagged rocks baked under a hazy sky. In some frames, you can even see parts of the lander itself, like the antenna or the camera housing. The rocks look strange at first, layered and interlocked, almost like cracked ceramic tiles. That's because Venus's intense heat and pressure deform everything. The planet's surface is 465 degrees C, and the atmospheric pressure is 92 times Earth's. Those slabs may have been formed from lava flows, fractured under stress, or thermally weathered by the harsh climate. Now, look at the colors. They're not natural the way we think of color. These are processed to reflect what the lander cameras saw under Venus's thick clouds. The hues are mostly yellows and browns, tinged by sulfur and heat distortion. This is Venus under its own light, filtered through an atmosphere we still don't fully understand. Then there are Magellan's radar maps. These aren't photographs. They're radar reflections converted into black and white or false color visuals, but they're just as real. Bright areas indicate rough terrain, mountains, ridges, or jagged lava fields. Darker areas show smooth plains or lower elevations. In many of these radar images, you'll spot vast volcanoes with wide domes and collapsed calderas. Some are larger than anything on Earth. Others are arranged in strange patterns, like tessera terrain where the crust has been crushed, folded, and bent over millions of years. And finally, Parker Solar Probe's visible light images. This is where things get strange. These are the first ever surface images of Venus captured using visible light from orbit. They show a faint, almost ghostly outline of the surface glowing through the nightside haze. You'll notice a soft glow. Regions like Aphrodite Terra appear as slightly brighter patches. It's not sunlight reflecting. It's the planet itself radiating heat, seen in a part of the light spectrum most cameras ignore. At first glance, these images might look like they're missing detail, but that's because they weren't designed for this. Parker's camera was built to stare at the sun, and yet, it still picked up the faint outline of real Venusian terrain in visible light That shouldn't have been possible, but it was. The key is this. Every one of these images, Venera, Magellan, Parker, shows a different layer of Venus. Not metaphorically, literally. Venera shows the ground up close, what you'd see if you were standing there. Magellan shows the topography, the layout of the land across the whole planet. And Parker shows the in-between, the glow of a world still hot, still changing, and still visible in ways we hadn't realized. None of these images are beautiful in the traditional sense. They're not made to impress. They're made to reveal. And that's what makes them so powerful. You're not looking at a digital render. You're not looking at a filtered approximation. You're looking at Venus as it actually is, in all its alien, hostile, violently active detail. And the more we look, the more we find. Right now, space agencies like NASA and ESA are building new missions designed specifically for Venus. NASA's Veritas will use radar to detect surface changes smaller than a meter. ESA's Envision will look deep into the crust for signs of tectonic activity. Da Vinci Plus will enter the atmosphere directly, measuring its chemical makeup during descent. These missions won't just fly by. They'll spend time studying Venus closely, trying to answer important questions about climate, volcanoes, habitability, and why Earth and Venus, so similar in size and location, turned out so differently. Venus might have once had oceans and possibly life. Then something changed. The atmosphere thickened, the surface heated up, and the planet became unrecognizable. Now, we have the tools to figure out what happened. And for the first time, we're in a position to get real answers.